Hello everyone, my name is Sethasarakvath and my partner is Davin. Today we are talking about CPU matrix. CPU matrix are value that reported by operating system to show how my CPU is being used. And to visualize that, we use the top command to observe those real-time changes. We will focus on 5 key points including system time, user time, idle time, night time, and waiting time. So first we have system time. System time is the percentage of CPU that spent on a system level task. That's also include a file system. And the highest system time is mean the system is doing a lot of internal work. In this case, we use the command find here, trying to search all the root directory for a whole file system to find the file with .conf here it means configuration, and then trying to hide those results because we don't want to flood it in our terminal. So in the first small terminal here, after running this command find here, as you can see, it has a permission denied. Why? Because if you're trying to search all those file system, some file will be owned by another user. So just like that. And then if we are looking in the big terminal, as you can see, after running the top, 45.8% of system time is used. It means like the nearly half of the CPU is very busy doing the system level tasks and trying to work to perform those search. That's it. And now it's about idle time. Idle time here is a percentage of CPU is doing nothing. The more highest idle time is mean like CPU is not under heavy load. Trying to use command top D top minus dash D one here is mean like in the top it's trying to reload it every 1 second. So the result of this terminal show that 97.8 of idle time, which means 97.3 of the CPU is doing nothing and free. And the baseline test, when you don't run the heavy process, the CPU is very low and the idle time is very high. So moving on to user time. User time is just a percentage or amount of time that CPU executing in the user level process. Example like if your user trying to play game application, that will be display and load up highest percent. So to test and visualize it, I test in my machine with only 2 core, and then I run this code. This code is just basically to push all those core of my machine to its limit, which means it's trying to loop forever and keep pushing the CPU to the 100% usage. So after creating this code script, and then we are running this command python 3 cpu.py, and this command I trying to run it in parallel and run it in the background, so that the CPU will be fully used. As you can see in the result in the top here, the CPU is 100% usage, which means all those CPU is being used, fully used. And the 2 core that I just mentioned is used and show clearly as an example in this htop. The core 0 here and core 1 here is 100% used, and that's all. And now moving on to my partner, is talking about night time.
Hello teacher, my name is Davin. So now I'm going to demonstrate about the night time. So the night time that I demonstrate, which is the CPU time just by low priority night process. So in here I using these 3 commands. This Python command and this one command. I start with the 2 normal priority, and this one the nice and minus n and Python this infinite loop. Yes, this is the one with the nice value of plus 10. So after I run in this command, the result that I got is like is equal 5%, which is the low priority loop. So the 2 normal loop using most of the CPU user time is about 94.9%. So the 9% only get CPU when the other 2 aren't using it, so it doesn't slow down the main task. So let's quick get into the limit a little bit. I want to demonstrate to you. So let's run this one and the normal 2.1. So I run this again. So and yes, the night here The first capture I see it increase up around 60%, yes, which is high. So this is the demonstration of night. So now let's get into input output rate. So now I'm gonna demonstrate the which is show CPU time spent waiting for input output like this, right? Instead of doing computation. I'm using this command, this for loop command, and I gonna explain this command as well. So this for I in curly bracket 1 to 4, this means that the loop run for time. So I will be 1, 2, 3, and 4. So do the dd if equal slash del slash 0. So in here it means that dd is in copy data, and f equal slash del slash 0 it means that its input is a stream of 0 byte. This is calling another way. We can call it dummy data. And for off equal big file, the size I, it means that it should create a different file, like big file 1, big file 2, big file 3, and big file 4. And the PS equal 1 M, it means that the block size is 1 megabyte. So each read write is done in 1 megabyte. And count 1,000, it means that it write 2,000. It's not 1,000, it's 2,000. 2,000 block time 1 megabyte, it will be equal to 2 gigabyte per file. So with this one aggregating 4 files, it means that it 8 gigabyte with 10 and run it in the background. So yes, as a result, as you can see in here, we get y is 13.1%. So now let's click into the demonstrate in Linux. So now I'm gonna run this command, and here take a look at y is 7, come up 7 and 3.5. So now I'm running out of space since yes, I have a lack of space. So the 7 that you see earlier, it means that the CPU is mostly idle, waiting for this to finish writing. And here for user time and system time are much lower because the CPU is computing the bottleneck is this. So to sum up, this shows how y indicate the system is input output bound rather than CPU bound. So that's it of the y, and thank you teacher for paying attention. Thank you.